complex, integrated. Each essential component dependent on the other. Your enterprise network, designed to save time, make more efficient use of time, speed time. But as the reliance on your network becomes even greater, as applications become more complex, offering even more ways for you to improve your time to market, reduce production times, speed customer response time, increase the value of the time spent on internal communications. Something happens to network response time. And with the increasing demand for multimedia, imaging, high bandwidth technical applications, even the growing sophistication of standard applications such as embedded graphics and email, they take an exacting toll on network momentum. Network segmentation through bridging and routing offers some relief, but adds latency, complexity, and expense while providing only a short-term solution. Madge provides the momentum to a logical migration path, clear visibility for a seamless integration to ATM. The key component is token ring switching. Unlike traditional bridges and routers which store and forward packets, introducing often unacceptable levels of delay, the token ring switch transfers packets on the fly. This means that communication between rings takes place at almost the exact speed as over a single ring. Switching allows you to build networks with smaller segments so that stations are sharing the available 16 megabytes per second bandwidth with fewer devices. A server which otherwise may be very heavily loaded can be put on its own ring to improve performance. In this case, the server can be plugged directly into one of the ports on the switch, providing the server its own dedicated bandwidth. Servers read and write data at the same time. With token ring switching, the link between the server and the switch is bidirectional, providing 16 megabyte per second transmission in both directions simultaneously, effectively doubling the available bandwidth. Token ring switching also supports virtual LANs. Virtual LANs allow you to build logical associations of physical segments that may be located in different parts of the network. Users of stations on the virtual LAN can communicate with other stations on the virtual LAN just as if they were on the same physical segment. Virtual LANs are defined by intelligent filtering of broadcast packets in the switches. You're able to ensure that users on a virtual LAN only see broadcasts that originate from the servers on their virtual LAN. This provides additional security as well as minimizes bandwidth utilization from broadcast traffic. Token ring ports on the switch can be used to support the connection of workgroups through existing hubs. Servers can be connected to shared rings on hubs or directly to a port on the switch for full duplex connections. Servers can also be connected to the FDDI ring that links the switches for high-speed access through the 100 megabyte per second FDDI interfaces. The FDDI connections on the switch offer dual-attach FDDI interfaces, which allow switches to be connected together by fiber cabling without the need for an FDDI hub. When you are ready to deploy ATM at your backbone, your high-speed servers can be connected directly to the ATM switch, typically at 155 megabytes per second. When used with ATM, the token ring switches are converting token ring packets to ATM cells using a technology called LAN emulation. With LAN emulation, an ATM network can be made to act like a token ring and token ring packets carried across it. This makes it possible to switch token ring packets directly into ATM, preserving your investment in Token Ring. In effect, you are able to create a fully software-defined backbone, making it very easy to reconfigure when adds, moves, or changes occur. Token Ring, time-tested technology like that of the master clock builders. Madge has set the momentum to switch networks into high gear and lead Token Ring into the future.